Hello, everyone. We will be going through section 2.6 on molecular and ionic compounds. This is the section where we get to start looking at how the elements combine to form compounds and kind of predicting ways in which that might happen. So the learning objectives here define ionic and molecular or covalent compounds, predict the type of compound formed from elements based on their location within the periodic table, and determine formulas for simple ionic compounds. So we're going to start with kind of where we left off in the last section, looking at what happens when a sodium atom loses an electron. So if a sodium loses an electron, we end up with a +1 ion. And it turns out that we can fairly easily predict what kind of a charge we will have based on where we're located on the periodic table. And I mentioned last time, we'll come back and talk about this and what you'll need to remember. And so we'll go ahead and do that here. So sodium, of course, is right here. It's in group 1. So the group 1 elements will tend to have a +1 charge. We're leaving out hydrogen, you'll notice here. So hydrogen is doing other things, but the other group 1 elements will have a +1 charge. So you want to remember that. The group 2 elements will have a +2 charge. Okay, so you want to remember that. Hopefully those two are easy to remember. So group 1 +1. Group 2 +2. We're going to go over to the other end of the periodic table. Noble gases, we already said, don't tend to form compounds, so we're just going to kind of ignore them for this section. But for the halogens, we tend to be a -1. It turns out, if you look at this, so +1 over here, kind of right after the noble gases are +1, kind of right before the noble gases are -1. That's not an accident. So think about the proximity to the noble gases will tell you something about the charge. -1 over here, +1 over here. So remember, halogens are -1. And then as you go out, the next group is a -2. So for group 16. And if you go out one more, that group is a -3 for group 15. I know there's a -4 here. Typically, we don't look at this forming a charge. It does other things instead. But then for group 13, aluminum will be a +3. Now that might seem odd, that why do we go from, maybe a -4 to a +3? But if you look at it from the other direction, we have +1, +2, and then we skip all of this and we have a +3. So it kind of makes sense there. Again, in this region of the periodic table, we have a lot of variability. We're still not going to need to know that for now. So we'll talk in the next section what to do with that variability, but you're never going to have to really memorize these for this course. What you need to know is group 1, group 2, aluminum, group 15, 16, 17. So know the charges for those groups. And what we'll be doing with that information is we'll be using it to predict the ionic compounds that form when we combine elements, as we'll see here shortly. So what ends up happening with these elements that form charges is we form what are called monatomic ions. So a monatomic ion is an ion where we have one element with basically a charge. We also have what are called polyatomic ions. I'm going to skip over that for now. That's something we'll come back to, I believe, in the next section. So this is a table of polyatomic ions, and we'll be going through this in the lab. We'll talk about what to do with polyatomic ions. So for now, we'll just leave that aside, but it's something we'll come back to. So what ends up happening with these elements that can form ions is if you have an ion with a positive charge and you have another ion with a negative charge, those opposite charges will then attract and we form ionic bonds because of that. So ionic bonds form when we have opposite charges, so negative charges with positive charges, and that will be cations and anions. So if you have an element that will form a positive charge and an element that will form a negative charge, and you bring those together, you get an ionic bond. So if we think about it, if you think about that periodic table, and let's actually scroll back up to that. The elements that formed positive charges, the cations, are all going to be metals. So not just these ones, but the ones over here as well. The elements that formed negative charges are pretty much going to be non-metals, although perhaps some metalloids in some cases. So the anions are non-metals, cations are metals. So when we have these ionic bonds, the way it pretty much always works is you have a metal with a nonmetal. Metal and nonmetal together, positive charge and negative charge together, you end up with an ionic bond. So the best way to recognize when you have an ionic compound is when you have a compound that contains the first element is a metal, the second element is a nonmetal. So that is how you make that decision. Now, the other kind of thing that can happen is something called a covalent bond. So let's talk a little bit about covalent bonds. In a covalent bond, we're not having these positive and negative charges. What we're doing instead is we're sharing electrons. We talked about molecules earlier, and I think I told you that some things are molecules and some things end up not forming molecules. It turns out that we technically only have a molecule when we have covalent bonds. So these ionic bonds don't actually form molecules, they form ionic compounds. So we have two categories here of compounds. We have molecular compounds and we have ionic compounds. Molecular compounds have covalent bonds. Ionic compounds have cations and anions, so metals and nonmetals. It turns out that for these covalent bonds, we typically are going to have just nonmetals there. And we'll see a little bit about that here shortly. So let's talk a little bit about ionic compounds. So in an ionic compound, again, we have a metal and a nonmetal. I'm going to go ahead and highlight those just to help us remember that is what we really need in an ionic compound is a metal and a nonmetal together. So we're gaining electrons with the nonmetal, losing electrons with the metal to balance the charge. These ionic compounds will tend to be crystalline structures with very high melting points. So a great example of this would be table salt. So if you think of table salt, you don't really melt it. It's more of a crystalline structure, but it does dissolve in water. So they are sometimes very water soluble, which is different than melting. This is not an experiment we would do where we melt the sodium, but we can see that it does conduct electricity if that were to happen. So in an ionic compound, we have a balanced charge. So the number of positive charges and the number of negative charges have to be exactly the same. And you could have a case where the positive charges are larger, negative charges are smaller, and you have to have more negatives to balance the positives, or vice versa. So we want to look at how we make that kind of prediction. Um, let's go ahead and look at this example. So if you have aluminum with a +3 charge and we have oxygen with a -2 charge, we want to know the formula of the compound that forms here. Now, as we look at this, it is within the question giving you the charges of +3 and -2. But eventually you'll have to be able to know if you see aluminum and you see oxygen, you'll know that aluminum is a +3, oxygen is a -2. We're going to be doing a bit more work on this kind of decision in lab, but just be aware that that's something you'll need to be able to do. So what we can do to look at this is we can say, if we have a +3 charge, we need to have 2 of those to balance 3 -2s. So you have, you're basically looking for essentially a common factor there, which in this case is 6. So 2 times 3 is a +6, and 3 times -2 is a -6. So then those charges balance. So the formula would then be, we have 2 aluminums and we have 3 oxides. So the formula would be Al2 for the 2 aluminums, O3 for the 3 oxygens. So that's how we would go about making that decision. We will sometimes have ionic compounds with these polyatomic ions. Again, this is something we'll talk about more during the lab session. And I'll also mention that in terms of the balancing of the ionic compounds, we'll talk about that more during lab. I wanted to give a brief introduction to it as part of this section because this is where it does show up in your textbook, but incorporating that into basically section 2.7 is how we have traditionally done this. So we'll discuss that more when we get to the lab. So a little bit about molecular compounds, and this is something we'll get into in much more detail later in the semester. So in a molecular compound, we are sharing the electrons. So molecular compounds are sharing electrons, and for this to happen, we basically need to have combinations of nonmetals. Okay, so combination of nonmetals is what's going to give you a molecular compound, are combinations of nonmetals. Molecular compounds will, unlike ionic compounds, tend to form things that are often liquids and gases. So if you think of, we've already talked about O2 and H2 are gases. Those are molecular compounds. They are combinations of nonmetals. For now, we're looking at kind of this binary of things are either ionic or molecular, but there are kind of in-between things, and those are things that would be explored in a higher level course. But it's useful at this point to discuss these kind of two extremes where with a molecular compound, everything is shared, and with an ionic compound, everything is transferred. I wanted to just briefly introduce a few things in terms of 2.7, but we're going to go through this during our lab time. 2.7 is about chemical nomenclature, which is the process of naming compounds. The reason we go through this in lab is because it is very important in the lab that if you are picking up a chemical, that you're picking up the right chemical, and that means that you can read the name of it and know what it is. So if you're needing to grab sodium hydroxide and you grab sodium chloride, you're going to get something very different than you expected. So that's why we go through this as part of a lab activity. It's also something where we do sometimes need to have a little bit more memorization, although I don't generally think that's the best way to learn. When you're in an environment where you're hands on and you need to pick things up, you need to be able to grab the right thing. So that's why we have a little bit of that. We'll talk about that in more detail during lab. I did want to leave you with, however, that part of the reason for this kind of segue is because the most important thing when we name compounds is making that decision of whether we have an ionic compound or a molecular compound. So my advice to you prior to the lab is that you go through the worksheets related to making that decision about is this ionic or molecular. And if you're able to make that decision, I think you're on the right place to get started on the lab. If you need a little bit more work on the balancing of the ionic compounds, that's actually something we do as part of the lab. So feel free to wait until lab time to complete that. Um, but this will be the last video for this module, and then we'll kind of finish up with the nomenclature as the lab.